Alright, I think I actually, yeah, I didn't have my mic muted, so. Alright, we're gonna go ahead and get this started. Yeah. Alright. So, brief recap of where we came from, where we are, and where we're going. Where we came from is I was just trying to solve this really trivial leak code problem. And I was like, oh, this is actually so easy. Let's try something more complicated. Let's try something more complicated. And that more complicated thing was using these SIMD instructions, single instruction, multiple data, using SIMD instructions to process the strings, because then we can process more than one character of the string at a time, like making use of the parallel aspect of the hardware. And so there's been a lot of things to learn along the way. Like, a string can be any number of characters long, but these SIMD instructions can only load a certain number of characters. Yeah, these SIMD instructions work on registers, so like the certain amount of data can fit in there. How do you get the data into SIMD? And then how do you calculate less than? And we did some stuff, instead of looking at less than, we did some stuff about we wanted to do greater than or equal. And so this is a little thing that we did for that, and it worked, but then we realized less than worked better. And then this is actually something we did last week, and that was like using a left shift or a right shift, shifting the bits right, and then a mask, then a mask to basically get the value that we wanted in the register. This is all getting kind of complicated, but like the result of this compare less than or equal, like if it is less than, then it's going to put a 255 in 8 bits of this big 128-bit register. Okay. Well, we don't want 255, we wanted 1. So this is a way of basically dividing 255 by 255 to get 1. And the reason we want 1 is because part of the implementation of the algorithm is, we need to do basically like result plus equals result. But if you do 250, if you're looking at 8 bits and you do 255 plus 255, you're going to overflow and you're going to get wrap. And so we wouldn't be able to return the right value we need to return from this. So we really needed to be able to get the value from the comparison to be 1 instead of 255. And that also solves some other problems. I'll probably make like a summary video sometime to highlight all the problems. But tonight, the thing that I really want to finish is, obviously this isn't going to compile. We figured that out. But, like how do we convert the algorithm? Now that it seems like we know most of the missing pieces of the puzzle at this point, except for converting the algorithm itself to use these instructions. And so there's a few things that are complicated about it. Figured out that only this load instruction is only going to load the 16 characters worth of a string at a time. So if your string is less than 16 characters, well, you're going to get a problem there because you're basically going off. You're reading. You try to load 16 characters of a 4-character string. Well, you're off and you're doing like a memory over. You're basically like going off the end of the array, basically. And then if your string is more than 16, then obviously you have to process that string twice with these. So there's a lot of things. And so we figured out, starting off the algorithm, if the length of a string is less than 16, just don't use this algorithm. Just go use the simple algorithm that we already implemented. There's probably something we could do there, but you know, not going to elaborate on that until we get like the rest of this stuff. So then it's like this is something about like how many times we had to process. Yeah, it's been working on this for so long, I'm starting to forget some of the stuff I implemented. But this is like figuring out, virtual in our case means like we're kind of processing a virtual string. And so how many loops do we have to do to capture the length of the virtual string? And then here we're looking at the length of a string and dividing them by 16. So, you know, if this result is 0, we need to actually handle that case. Although this shouldn't result in 0 because we did this check here. So it should at least be 1. So it's 1, and then we also do the mod to get how much is left over. So it's like we'll have to do like the main processing loop, and then for however if this is something other than 0, we'll have to do like a post-processing loop. So I have some amazing documentation here, more like a note to myself. All right, so at this point, I'm probably gonna like not narrate so much and just like sit here and look at this code and try to figure out how to implement it. Yeah, so let's see. So here I'm like setting up, getting the strings that I want to process. Here I'm like pointing what I'm calling a cursor at the part of the string I want to process. So I've loaded it up. So I have two strings loaded up, ready for comparison. And I want to check I want to do my test here. So I do need some way of accumulating the result. All right, so we do this. All right. Yeah, so looking at our existing loop, yeah, no, I'm not actually going to use that as a reference. Yeah, our simple solution, for each letter of a string, we go for each character in a string. That's actually saying it the wrong. We do an outer loop that's as long as the strings that are passed in. So like every string passed in has the same length. So the outer for loop is saying we are going to process every character in the strings that were passed in. This inner loop says now we're going to go down the length of how the virtual string length, which is like how many strings were passed in. Right? That's our simple loop. And we kind of have a similar thing going on here. I don't know why I have this note about 3 strings come in. I think this is saying, yeah, I literally have no idea. So I'm going to take that note out. I don't remember my logic here. This is the problem of splitting this up over so many different, over the last couple of weeks, is like I should be writing better notes is I guess what the real problem is. All right, let me lean back here. I'm like right in the freaking, I'm right up against the webcam here. All right. All right, I'm going to be quiet for a couple minutes and think about this code. Just writing out some notes, just in case we don't finish this tonight. All right. I don't know the answer to my question here. All right, so first, this actually, okay, yeah, so we get the first two strings, okay. Point the cursor at the beginning of them. Load them up. Okay. Now we want to do this. All right. So we do our comparison. Then we want to do, is that the compare less than? Yeah, then we want to do this part. Oops. Then we want to do this part. This is okay. All right. So now we've done the result. So now what we actually want to do is we want to accumulate this result. So this isn't actually what, so this is like, this actually all needs to be, oh shoot. I forget what the thing to select next is. I forget my shortcut for that, but this actually want to be like temp. A temporary result. An intermediate result. Okay. And then what we want to do is we need some kind of like way to accumulate the result in here. So for that, I'm gonna go to the intent. Should probably not use like my personal browser there. Let's use there we go. Let's do lost my train of thought. Let's do Intel. All right. Intrinsics guide. Add packed 8-bit integers in A and B and store the result. So I think what we want to do is this. We want this one. We basically want this. All right. So this is what we want. All right. And then what we have to do is if we go through this loop, oh, wait. This is wrong. Well, no. It's not necessarily wrong. That's a funny way to say it. So the way I have it written here is it's gonna like it's gonna go through the length, this virtual string length. Maybe that's bad naming convention, I don't know. It's gonna go through this. It's gonna process the first 16 characters of all the strings. All right, then it's going to go up here and be like, oh no, the strings are longer than 16 characters. You need to go through it again. So I actually think I need to invert these loops, although I think well, it ends up being the same amount of work, really. What I would be interested to do is see if like there's a way to collapse this down into like a single pass. There probably is. And probably pursuing that would have been more valuable than what I'm doing right now. I don't know. We'll do that too, maybe. All right. Either way, this is going to go through the, if 7 strings came in, this should theoretically go through. That means we would have like a virtual count of 4. So this would loop 4 times. And then doing the first 16 characters. And then it would go out here and possibly do a second loop. And then it would, what we would want it to do is do the next batch of 16 characters. Yeah, which would be fine. So in that case, what we want instead, yeah, car count, so then it'd be 1. But what we want it to do is be like times 16, right? So that if it's 0, then it's 0, but if it's 1, then it moves to the 16th character. There is an odd situation of if the null terminator gets in there. We'll ignore the possibility of null being in a problem for now and see if it raises its ugly head. All right, so could probably calculate this. I guess it could be like yeah, that's actually wrong. Is what we want it to be I times 16. That would have got us. That would have got us. That would have got me anyway. So we want this to be offset. Cuckoo. All right. So then we get down, theoretically that works, and then we get down here, and we still have this remainder count that we need to deal with. What is the remainder count? The remainder count is the number of characters. Oh man, that's a hairy problem. Yeah, I'm starting to think I actually really hate this implementation. I think that's my main takeaway here. This sucks. I think probably what this means is that I'm approaching the solution the wrong way. I don't know. When things suck this bad, it's like a sign you're trying to force something. Like you're trying to force an implementation that just really doesn't want to be an implementation. Because now we've introduced this weird situation where, like, okay, we're done with this chunk, but now there's still, like, every single string still has, like, this, up like 15 characters. Yeah, up to 15 characters that didn't get processed yet. Although, I was going to say, like, we could just, like, you know, instead of incrementing this offset by 16, just increment it, you know, so that it aligns to the end of the string, basically. But what happens there is then we might duplicate some results. Yeah, we might duplicate some results. How would we not duplicate the results? Well, could have like a special loop. But the problem is the reason this is becoming a stumbling block is like, well, we would need like a separate implementation of this that could take in, like, if we get down to here and we want to process the remaining characters, right? We can't just call this because we don't have a way of constructing this data for that unless we put like a starting point. We put like a starting point index here. So then it's like you're not going to start at the first. Yeah, we're basically a starting index which would control this. Well, let's try that. It's like int start. We'll just call it, yeah, we'll call it start index. All right. And so here we'll just pass it and say 0. And then I don't know what that was. Some kind of wonder if we could flip this around. I want to look. It's too late to look at that. We don't care about that right now. All right. So, yeah, if rim count's greater than it's greater than 0, then we want to do rem stands for remainder, okay? We want to do the simple, and we're going to pass it our strings, and we're going to say start at we want to start at yes, I have to look at my keys. Talked about that already. Minus rim count. I'm sure this is going to be off by 1 or something like that. Maybe we should do rim count minus 1. So let's say this is 1. All right, then we want to do the length minus 1. So we just want to do the last character. I think that works. Let's just try. Okay, and then at the very end, we need to get this. So this result is in the M1 is in the SIMD format, so we can't have that. We need to get it into integer. So the way we figured out how to do that was all this, which is incredible that we had to do that. But we just have to. Just seems like it would be convenient to be like, have like a load to integer. Maybe it does have that. Like, these are loading it into this. It's not exporting it. So there needs to be like a export. What does store do? Yeah, no. I don't see any other types. Like, let's see, what does this one do? Store 32-bit integer from the first element of A. Huh. Is that what we want? No. I think that means like we only get, you know, if you do 128 divided by 32, what's that like? Can't do math in my head. You get the first one of those. That's not what we want. We want, yeah, we would want something that like, but I guess they can't do that because you could have data loss. Yeah, whatever. Anyway, that doesn't do what we want. We got to do it this way. There's probably a way we could like add things over into the first 64 element bits and then export that, but we won't look at that. There's probably a way to not have to do all this, but I'm not going to look at it right now. We're going to do this because we've tested it and we know it works. So then what we want to do here is we'll return sum plus rim result. Phew. Okay. Chances of this compiling, I would say 0. But that's okay. Okay, we've got this. Put it here. All right. Okay. And then, so then what we can do to test this. All right, just go ahead and comment out all this. So first we can do, why am I doing it out here in the middle? First we can do int main result and do a simple, oh wait, where do I put those? First, we'll get the known result, which uses the algorithm that passed. All right, and we could even go over here and make sure it passes. I don't know if you can change the. Yeah, you can't change the API here, so we have to deal with that. Let's see. Console. All right, let's first test it on the one that they gave us, so that we have a known result. All right. So, oh, but that's not long enough to get a result in our case. Well, okay. Well, we can test this, which we know should give us a result. We know that we should. Let's see. We know that we should get. It should at least 1, 2. We should get a result of 2 from our known result. Let's just validate that real quick. Do I have all my... Do I have my... Let me just real quick delete all this crap. Oh no. That would have deleted our actual code. That would have been so silly. How about I just delete this stuff? Okay. Now that would have been wild. Okay, yeah. Winning. Okay, there we go. But I didn't output the answer. We could step through and debug it. And let's just do cout. Alright. Just real quick. Taking a little break here, okay? Checking some news. Apparently I still have... Apparently I still have the gaming tag. Oops, gotta take off that tag. Just updating my stream a little bit. All right. Our result was 0. No. Well, we know that was wrong, right? Oh. Yeah, we know we... we know that the result should be at least 2, right? Don't think we need this stuff anymore. I don't understand why I have this break here. Right? We're going over the size. First off, let's... just leave it. Right? So we're saying if not greater than or equal to is less than, right? So this is a boneheaded equation. And right here, we're going over each of the characters of... Yeah. Oh, wait. This is virtual length. Right? Yeah, okay. Yeah, no, this makes sense. But it doesn't. What doesn't make sense is that our result was 0. Time to debug. Doesn't make any sense. Why is it got to be so complicated? Programming. Not even once. Let's make sure my streams... Let's make sure my audio on my stream is okay. Yep, audio on the stream is okay. Okay. All right. So let's go and do this. I hit 5 instead of F5. Okay. Known result is 0. Huh. Well, that is a bummer. Did we miss something else? What in the world could we have messed up? Oh, virtual length. Yeah. Okay. Yeah. That's not exactly. We were. This is from when we were experimenting with something else. Ah, Nuck and Futz. Hate it when I do that. When I open up 2 instances. Like, all right, what I really want is this. Now I want this. Let's just step through this real quick and see if that fixed anything. Known result is 2 now. Alright, so we go to the command line. Get 2. Alright, that fixed it. Alright. So now I don't remember why we have this as 0 sorted. Theoretically, these should have the same result. Huh? Tee-hee. What a bonehead. Oh my goodness. Good thing the compiler does what it does. Yeah. Known result. 2. Test result. Is not 2. Is definitely not 2. It is some big ass. It's something else that is. Yeah, that's not 2, my friends. Well, doesn't that just bite it? Yeah, step over it just for kicks, but yeah. All right. Okay. If I had to suspect anything, it would be the fact that this is not initialized, right? And then we just add something to it. So if we there's a bunch of tests we can do here. But let's just step through this real quick. All right, so go here. All right, virtual count. Since it's only 16, since there's only 2 strings, we expect this to be 1. Yes. We should not happen. So virtual count should stay 1. Okay. We expect remainder count to be, oh god damn. Shit. I hit F11 instead of F10. I don't have those keys memorized. All right. We expect this to be 1. Yes. We expect this to be 0. Yes. So we should only have to go through this once, right? But if we take a look at result, yeah, it's not 0. Those results are non-zero. Those results are non-zero. That was a bone-headed thing to say. What I'm trying to say is there's garbage in here. So when we go down here, yeah, so we start at 1 here, and virtual count is 1. And so we don't even get into this loop. So do we want less than or equal to 1? Yeah, I think so. All right. All right, so that's something we can fix. Let's fix that before we fix anything else. We probably should think about what the implications of this are, or the ramifications, but let's just do it and see what happens. That's a potential thing to come back to bite us. Bite me. Bite us. Yeah, bite me. All right. We got a breakpoint. Let's keep our breakpoint there. Let's go through and test what we think. We think we're going to get past this. We did. We are expecting this to be 1. It is 1. We're expecting this to be 1. Oh, god damn it. I hit F11 again. Car count, room count. We expect this to be 1. It is. Expect this to be 0. It is. This is full of garbage, which we are not sure if that's a problem or not. We go in here. We go in here. We expect to get into this loop. Okay, we got it. Okay. Now, since it's the first 16 characters, we are expecting this to have 2 true results. So if we go down here and we look at temp, well, we have to look at the hexadecimal. Yes, we have two true results, which gives us 4 Fs. And then by the time we get down to here, this process should convert those both to 1s. All right. Yeah, I'm a bonehead. Stop. Pause. Stop. Ugh, stop. I pressed the wrong thing. Okay. What was I doing? All right. Let's go all the way down to result. We're expecting these to be 1s. They are 1s. 0, 1, 0, 1. That is what we expect. Now when we add, we're expecting result to be identical to temp after this one. It is not. So the fact that there is stuff in result is a problem. So we can confirm that. By going down to here, and sum is not 2, which we would expect sum to be 2 if things had gone right. Do we have to do free? Is malloc? Do we have to call something to free that memory? I should check that. Okay. So this needs to be initialize. I know how we can do that. I'm pretty confident about how to do that. So if we do load, could we use... Yeah, this is what we want. We want to take, we want to do this. We want to do, well. All right, but instead of 0, 1, we just want this. Okay. All right. Now when we get back over here, we just expect, now we expect result to be all zeros, yes? Okay, then when we get down to here, we expect result to be the same as temp, and it is, all right? Then, all right, so now we can keep going, and then we do, well, by the time we get here, we're expecting sum to be 2. It is! Cool. So then, if we do, I don't know what just happened. I hit F10. I think I have an exception. Seems like an exception happened. That doesn't seem right. 2 and 2. I don't know why stepping over this failed. That doesn't seem right. But we did get a result of 2 and 2. Okay. So that's promising. So now let's test it. If we go we'll try 3 strings. So here we want like L, so what result are we asking here? So we would be expecting, oh well, let's, we expect to have to delete this column, so 1, 2 plus the 2 columns in it. So we're expecting a result of 4 now. Cool. So that worked. So that one was a test of using odd. Now the question is like, all right, now let's double it. So we would expect for this to result in 8. And now what we're testing is, does our other algorithm work for longer strings? That's cool. Now let's add some remainder. Which in this current test, we're not expecting it to add anything to the result. We should still get a result of 8. Cool. And then let's just check. Now we expect a result of 9. That's tight. All right. I think we're ready to go take this and put it on. I think we're ready to try this out on Leak Code. All right. Going to take a quick break, and then we're going to test this out on Leak Code. All right, coders. It's time. It is time to find out why our algorithm will not run on leak code. Well, leak code's not going to have the best code formatting. So I guess I will, well, they're not going to need all this. We really just need this. I have very, very low expectations here. All right, so like I think we messed something up there, right? Nope, there's this. Okay, for this, we're expecting these should all pass because they're all less than 16. So let's, I guess what we'll be finding out here is if this even compiles. Because we're using a Windows thing. God dang it. This always comes up. Bah. All right. Let's go fix this on our code side. So if we take this, if we just do this, we're going to get a compiler error now. And we will have to go figure out why. All right. We gotta go find a. And I also don't know that I want malloc. Like, if I remember correctly, isn't malloc heap? This is what I really want. And it's in standard lib. So if we go here, can we? Oh. What is this? Probably gonna get tons of failures now. Let's see, let's do this side by side here. So what's this size alignment and then size? So it's the reverse of this. So we want this. Excuse me. Oh wait. Is this a heap? Is alloc on the heap? Why? Just curious why. Undefined. Huh. Wait, did I reverse it? No. I don't understand this. Like, it seems as though we should be able to have one that we don't have to change based on whether we're on Windows. Like, I get it, okay? But guess I don't understand why I have to use this one. Why can't I use the C++ one? Why am I having to use a Windows specific? That's my question. Which is fine. You know, no problem there. Except for, like, I just would rather not. I don't have a philosophical reason why I cannot. Oh, interesting. Windows decided not to implement it. How crazy is that? Makes sense. Okay. So, that's okay. We can work around this. Where was that? That's right here. So we do want to, and we do want to reverse these things. My bad. Did I do that? We expect no change on this run. Can we specify test case? Can I like come over here and be like, now we're expecting a result of 8. Oh wait, 9. Yeah, we did. And it worked. Oh. I don't want to do this. I just thought I could heart that and it would take my... All right. This is the moment of truth. Boom, 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 boom. Submit. It compiled. It ran with this... Oh! Dang. So we only got through 34 of 85 test cases. Well, knuckin' Their expected answer was 25. Oh, they were expecting an answer of 25. Yeah, so I guess we didn't like thoroughly test. How long is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. So we output 25. And yeah, let's take this. Yeah, the problem is we don't have like a quick way to construct this. We had to be like push back. Blah, 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 blah. All right, well, that was semi-fun. Oh, geez. So we can comment this out. So I'm going to take this and be like, see. God dang it. It feels like my shortcuts on every computer are different, my keyboard bindings. So it's like, that isn't right. Like, select, change all. I did Control F2. Right? Control F2. Oh, okay. Ah, nuck and futs. Well, I don't want that. What's select next occurrence? Add. Control D. So I'm going to be like, yeah. Oops. I need like an opposite of that. Remove last occurrence. I'm just trying to format this in a fast, easy way to make it a test in our case. We could probably like, we could probably put these as inputs as command line inputs. That would be smart. Okay, we need to remove last occurrence. The problem is I keep going too far. I see. I don't know what the last string is here, so ZZZ, all Z's. All right, so all right, now you're just watching me struggle with formatting this stuff. It'd probably be faster. Okay. That's all I wanted to do. All right, now we can go remove these guys. Okay, and then what we should be able to do is go over here and be like, oh, no, Control Z. Test and place. Wait, test. There we go. Maniacal laugh. Okay, so now we're expecting theoretically 9 and 9, but we are not going to get that according to. Oh, god dang. We need to have a little. I don't think we need either of those, right? Bummer. So we got way too big of a result. Time for some debugging. Might save debugging for tomorrow night, honestly. We'll debug this for a little bit, but we're going to have to go tomorrow night. We know some things work. So Yeah, let's get our deep breakpoint here. So F5. So let's just collect. Let's get a little data here. So stirs dot size E. What's that? 15, 14, 14. All right. So we're passing in a total of 14. So that's our string length. So we're expecting to have to process this 7 times. What do I mean by that? I mean that virtual count should be 7. 7. It should stay 7. Still 7. All right, so let's take this out and do virtual count. No, let's keep that. Okay. Character count. So they're all 20. So that means we should do once and then have a remainder of 4 to process. So we're expecting car count to be 1. It is. And then remainder count should be 4. Oh, you guys. Oh, yeah, you can. Okay. Is there a way to increase the... Okay, I can increase the size up there, but I don't think I can't change the size. Search depth. You know, I don't actually know what search depth does, and I just now noticed it for the first time. I'll have to learn that. All right. Okay. Room counts for it. So here we're just zeroing that out. It doesn't do anything. All right. So car count is 1. So we should only have to go through this. But virtual count is 7. Yeah, so we had to go down the whole list of strings. All right. So we get the first 2 strings. We get strings 0 and string 1. Right? Yeah, 0 and 1. Okay. Load them up. Calculate a result. I think we just got a problem. Yeah, we did, right? What is this? That doesn't make sense. Okay, let's stop and rerun that. That didn't make sense. Let's take a look at temp. Oh. So temp got effed up. Okay. Let's run. I really need to memorize my F keys. All right. Let's see if temp is always messed up. hexadecimal is what? So, okay, all this is telling is that there was one thing that didn't match, okay? And so we expect that to turn to 0, 1. Okay, it did. Okay. And results should be the same thing. Is there any result here? Right. So results should all be zeros, and now it should be 1. Oh, it should have a 1 in the same spot. It does. Okay. That did not get messed up. My bad. My bad. All right. So now we're going to go. Now we should be doing string. We did 0, 1. Now we should be doing 2 in 1. Right? 2. Let's J is 2. Just put that up like here. Oops. Oh, that was not what I wanted. All right. So J is 2. So J minus 1 is 1. All right. And I think we didn't. I think we didn't. Let's see. Yeah. If we only do so there's a total of 14 strings, right? We're only going to do 7 of them. Yeah, we're only going to do 7 of those. I think I was wrong about that. We have to do, right? Because J is just going to go to virtual count. But virtual count is half the length. So we're only going to do, yeah, that's obviously wrong. Obviously wrong. I don't know why I always go back there to do my editing. I can do it right here. So, yeah. I think we don't even need that. We can just do this, right? Can we... Let's turn that off. Let's turn these off. Oh, I just prefer to edit in Visual Studio Code. It makes more sense to me. Like, it just makes more sense to me. It makes more sense. All right. Right, let's compile that. Let's go back. Thank you, Windows. And I can run it from here. That's never what you want. Yeah, when your code does that, it crashed. It crashed. How was my code working in the first place? Huh? I never tested this many. I don't need this anymore. Yeah, when it does that little hang right there, it doesn't just, and then it doesn't print out the result, that means that means an exception occurred that you didn't handle. Something crashed that you didn't handle. So like if we turn off this, yeah, see, it didn't hang and it printed out the results. So something in our code is crashing. Something in our code is crashing. That's going to make a book called Something in Our Code is Crashing. Tales of a Mediocre Programmer. All right. So what we have to do is go find that crash. Probably help ourselves with some assertions. I should think about that. And let's take a look at what could possibly. So string size. Oh well. Now this is always going to be at least 1, so I think we don't need this less than or equal to, because if we do less, if we do equal, yeah, this is going to be off the end, right? So we can go here and do this. Yeah. So that immediately was a warning sign. Okay, so now it runs, but our answer is wonky donkey. Let's go find out why. I'll probably only give this like a few more, like 10 to 15 more minutes. All right, so we're expecting now for our virtual count is 14, so we are going to go through the entire length. Yeah. Character count should be 1. And remainder count should be 4. Okay. Result we zeroed out. So now we get. Oh, this part is going to be wonky, right? No. This doesn't say it. This doesn't change. All right. So now we're doing 0 and 1. Oh, I know what's the problem. I know. We don't have the concept of here in this algorithm we break, right? Yeah. In this algorithm we break because as soon as we find something that's not alphabetical, we just count that column, right? Like if a column has more than one thing out of alphabetical order, it really doesn't matter. You're only going to delete that column once. So we don't have that. If we took off this, now we get the same answers. So that's the source of the problem. We need this concept of a break, which I think we had to use a mask. But it doesn't make sense to keep processing. You know what I mean? Like, if this... No, we had to keep going. Yeah. What we want is some kind of mask, right? So that once we want some kind of mask though, so that this actually does not accumulate. It's like if there's a result if it's already 1, you don't do anything. Is that an or? Right? time for some OneNote. Got it fired up. Okay. I'm going to take a drink of water real quick. Oh, yeah. Okay. So let's say we already have a result of this, right? And we get another result of that. I guess we could just do and, right? If we do this, I guess what we instead of doing an add, instead of doing add, we just want to and it. And because then we'll just get what we had. And then we don't do an add until the very end. Okay, I think that's what we want. Yeah, it's not an or. No, or would not give us what we want, but an and would. So this was the and, yeah, right? So what we really want, we don't actually want this. We want another one of these. No. The reason that this will not work, the reason this and will not work is this. The reason the and won't work is that we already have zeros. Our result is initialized to zeros, right? So we'll never. So I think what we do is we do want an or, right? Because then we will get this. If we did an and, we would just get zeros, right? And then if we got this again and did an or, we would still get this. Yeah, so we want an or, which I do not know. Is that logical? Logical. Perfectly logical. Yeah, that's what we want right there. Logical. Perfectly logical. I think that's what we want. All right. What's going on here? Why am I getting so many? Yeah! Pew, pew. It worked. Oh, wait. Yeah, with that. Yeah, boy. All right. Hallelujah. I need a soundboard. That's the next week's project. Make soundboards. All right, here we go. So yeah, we don't want this. Let's just grab it out of here. We want this. Right. How did it not work for this one? We got it, that one. We got the harder one. We failed the easy one. Grrr. I can't even. Why? What changed? What changed? Well, we know exactly what changed. Because we changed it. Well, poo. I guess we got to step through it. What is wrong? I guess it's something to do with the virtual count. I think there's like a condition here that we're not accounting for. All right, so we're expecting this to be 3. It's 3. We're expecting this to be 1. It's 2. It's 2. Well, why? Length 37. Okay. Did we make it 37? Yeah, I guess so, because we cut and pasted a few times. All right. So that means we're expecting to do, 2 loops. And so that would give us 32. So we're expecting this to be 5. Yay. Okay. We zero out our result. So we're going to go through twice. Okay. That's probably where things are going to get tricky, is that we're going to go through twice. So, why did it work? Why did it work when, like, if we go back and do it, if we go back and add this stuff, this janky stuff in here. It got even worse. All right, so we know that's not the problem. That's good. That's inspiring. Okay. So what happens? My suspicion is that it messes up. Let's think about this. So the first time we go here, we're going to load it at offset. So we should be loading 0 through 15, right? So if we go and we look at A, wait, what's happening to, oh my, I had my pen on, my Wacom tablet pen on, it was messing up with the cursor. All right, anyway, we go look at A, all right, the contents of A. Copy. We would expect the contents of A because we're at A is 0, is the string 0. So if we look at we're at all the way up through elemental P. So if we calculate this, so we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Elemental P. Yes, that's what we expect, right? So that's cool. And we would expect B to be basically the same thing. Yes, they are the same thing. Well, you know, they both end with elemental P. All right, that's what we expect. All right, it's 3. Okay, and we'll do this again, and we're expecting the same thing, right? Because it's still on like the first 16 columns. All right, but then we're gonna go and now what we would be expecting is to start at A. So, and we should go to here. Okay. We do? Yeah. A, B, A, B, B. Oh, wait. Yeah. Oh, wait. We're at J is equal to 1. So we should be looking at the second part of this and this. So, yeah. So A, B, B. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we should end up P. Yep. All right. That seems right. Okay. So now we should, in B, we should have, in B, we should have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we should have like the LL. Yeah, we do. Okay. So that's right. Okay. Cool. rim count is 5. Okay. Oh, I know what the problem is. Maybe. So we should be done. We are. Rim count is greater than this. So what we should be expecting, what we would be expecting simple to calculate now is from P minus 5. So one, two, three, 4, 5. So it should start at L, right? So it'd be comparing these things. That's what we expect, right? Okay. Start index is, 32. Yeah, 32 is right. So we would expect, I'm going to count this out. You're in for a real treat here. Best stream on Twitch. Going to count. So we're expecting 32. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Oh, I think we went too far. Yeah. So if we go do L. The first one is L. No, that's right. Yeah, that's right. So we would expect the result from processing this part to be, we would expect the result from here to be 1, right? From just processing from here forward, we're expecting the result to just be 1. So 1. So rim result is 1. All right, cool. Well, always nice when things. Let's go to here and sum. Four. Well, that's not what we were expecting. All right, so something is going wrong. Oh. Yeah, I'm a bonehead. This all comes back to being a bonehead. So or works sort of. All right. So we do or. We didn't go far enough. All right. So we get this. And then if we do or, but then if we have a result that comes in like this, right? And we do or again, or. No. No, I'm wrong. No, I'm wrong. Sorry. I thought what we were doing is overwriting something. So we can backtrack this and see where the algorithm goes wrong. So we know if we go to here, so let's first just do 2, right? Let's see if it's that third. Nope. So that has nothing to do with it. That's good. All right. Let's all right, I got to go back to Visual VS Code because my multi-line editing is better in this. All right, what we want to do is just take this back to a known. Right. Here we know there's, so we're expecting 1. I think we're expecting an answer of 2, 3. Expecting an answer of 3. Oh, 4. Okay, so we know that if it's the first 16, it passes. So now we're still expecting the answer to be 4. I'm going to turn off that. I'm going to take off this verbose because it's just adding a lot of stuff we don't need. 4, right? Okay. So that's 2 loops through. And then let's just add, oops. So now we're still doing the same, we still expect the same result. All right, yeah, I gotta cut the stream off in a few minutes here. Okay. Now we're expecting a result of 5. Oh. That's bad. Huh. It has to get... So something about my code is triggering a virus scan. Well, that's a pain in the ass. I don't want that. So... I don't even understand at this point what the problem is. Yeah, Visual Studio Code doesn't know about these kinds of... So this one's only 4, this one's 5 long? All right, so the only difference between these two things is... All right, yeah, I'd have to stick to one thing for code editing. QRST... Okay. Okay, now we're expecting 10. Yeah, we're expecting 6. Yeah. Yeah. All right. So I think it's if we mess something up in here. That's where the problem comes. We do. Now we're expecting 7. But I think this is where we'll get a problem. What the deuce? What the heck? Let's change these ones. Oh god. What the heck? I was just taking this out to visualize, okay? This should yield the same result. The same flawed result. Yep. Alright. So, anyway, so within the first one, we're expecting 1, 2. Right, we're expecting 1. Are we somehow double counting? But I don't know that there's a way to double count. We did. Oh no, I thought we left. No, I'm an idiot. I got overexcited at an easy solution. I'm just really confused of like why this one has a problem and this one didn't. All right, how about this? Let's try to like what about our data here is different? And because that and like the one I see is right here, so that's like the that JKLM. So let's change this one to L. And now let's see if that breaks it. It did. Okay. What about the fact and then let's test and see if it's specifically in the last one. Okay, doesn't matter that it doesn't, last doesn't matter this direction. It just matters that it's in that spot. And then let's say, let's take this one and be like, okay, so it's just that spot. How weird is that? Are you kidding me? All right. So it's just this spot. Well, we know it's this spot. Let's try this one. This is fascinating. Okay, so let's see what's unique about this spot. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's at the 12th spot. All right, we'll have to step through this. All right. So offset is equal to 0. So be nice if we could get the ASCII view here, right? Okay. So we're expecting like 1, 2, right? Well, no, we're not. We're expecting one result here and one result here. So we're expecting an F and an F in temp. Yes, or 10101. Yes. So and then we're going to expect result to be that. Okay. Now we should be done. Okay, no, now we got one more. Well, we don't really care at this point because we already know this part works. So we know, so we expect result to maybe get something extra. Yeah. Oh, wait. Oh, yeah, that's fine. It's just... Oh, wait. No, that should be fine. Now our offset should be 16. Oh, I'm hitting F11 again. Is this possible we do something wrong here? I don't think so, right? I'm having a hard time. I'm having a hard time with this, as you can see. Let's see. So offset. J is 2, right? So J is 2, so that means that A is in J equals 1. A is currently having this string loaded into it, right? So we can see that is right here. We have the K L L N O P right here, NOP, right? Starts at A, B, C, D, E, A, G, H, I, H, K, L, L. Okay. And then we step. Now it should be this one here. It's like A, B, C, D, E, F, G, H, I, H. K, L, M, N, O, P. Yep. That's right. Nothing's wrong so far. So what address do we put here? Believe this one is shoot. Here I am leaning forward again. So A is FFB30, FFB20, B. Yeah, so A has the LL. And B has this one, right? L. So we know like this compare is in this one. L is less than, and this one should be false, right? M is not less than L. So in the 16th spot, so we would expect in the 15th slot 15, 14, 13, 12. In the 12th spot, we should expect a 0. Right? When we do this compare, we are expecting there to be a 0 in the 12th spot. Because we already got the difference in the first one. Yeah, temp was all zeros. All right, so now result is going to get ORed with all zeros. Oh, is it 0 and 0 is 1? No. We would expect here, since temp is all zeros, we are expecting result to not change. And it didn't. Am I missing something here? Did I? Did I flip these around and forget to flip them back? Something is wonky at this point. Size alignment. Nope. Size alignment. Yo, what the heck? Okay. Well, we had to do a little bit of analysis, right? It's a bit hard to do because, like, it's a bit hard to do, but we need to figure out, like, what answer we would be expecting. Well, no, because if we take, I think, if we take off, do we test, like, if we go over here, if we go and we take this stuff off, do we test that? Yeah, so it doesn't have anything to do with those. It has to do with... And I think it doesn't have to do with, like... If we go and we get rid of all this too, right? No, it doesn't... We weren't getting... Let's... Okay, so it doesn't have to do with that. Blah, 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 blah. It's not... it's not checking the diff the way I want. I think it'd be like... This is dumb. This is not what I want. Yeah, so it's stream. Yeah, that isn't gonna work. The problem is it's hard for me to go through and calculate, like, okay, all right, well, we just got a result of 4, so we know up to here we're expecting a result of 4, right? And we know from here we're expecting a result of 1. So that's our 5. Okay. And if we are expecting 8. So there's 3 in here. All right. So okay, so this one would get kicked out. So there's 1. Two. Wait. Am I losing my mind? I think I am losing my mind. We know there's 4 in this, right? We can look at this and be there's 1, 5. And then we only found 2 in there. All right, I'm going to test this and then call it a night. It's pretty cool that we got the algorithm kind of working, but it's kind of a bummer that we have gotten... Let's remove this test case here, right? How was I removing test cases before? Wait. Ah. I don't understand. Okay, so A is correct. A is correct. So where are we wrong? Right. So, oh, it's right here. So 1, right? 1, 2, what the heck? I'm losing my mind. I think I've forgotten something at this point. There's 4 there, right? And if we get rid of all this, that should give us 5. Oh, 6. Oh, yeah, 1, 2. All right. Yeah, all right. So there are 2 there. So, and there's 1, 2 here, right? So let's see if we do this one. If we do, I should make this something to input so that I don't have to like test. I don't have to compile every time. Yeah, it really just seems to be this spot right here. So there's still the one there, yeah. Yeah. So it's really just, and if we put it up at the top. Yeah, that is still this is still alphabetical. Oh, this isn't a valid test case. Yeah, this isn't a valid test case. Because it should be fine, right? Yeah. Oh, so adding it there breaks it too. So if I do, huh? So weird, man. Alright, I'm giving this 5 more minutes and then we're calling it. Debug it tomorrow. So in this case, ML, this is false. Right? L is not less than M. But then we go and we say so in the first case here, this one should result in a result of 1. In the second case, it will result in 0. So I guess I wonder if the question is like, does something get overwritten? Alright, so let's go. Yeah, if I made this something that could be passed in, then I wouldn't have to be doing all this recompiling. This definitely slowing me down. So that is in the... What did we calculate? So this is the 15th spot. So 15, 14, 13, 12, 11, 10, 9, 8. So it's in the 7th spot. Well, from the back. From the end. So... Alright. It's on the second. It's on the second loop, right? No, it's in the second loop of this one. So, right now with temp, we have just compared this and this. So we would expect there to be a 1. We would expect there to be a 1 or a 255 in the 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5 in the spot 5, 6, 7, 8, 9, 10, 11, 12, and in the 12th spot. Zero. Wish these numbers were bigger. Let's make our lives easier. Let's go look at it in the address in memory. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? We're going to convert those to ones. Okay, my batteries. So now we should have a 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So everything's okay. Now we are expecting result. Oh, I get it. I get it. Ah, I get it. This is a dumb. Oh, I should have gotten this a long time ago, too. Crud. Yeah. I should have gotten this a long time ago. So from our first pass, so when we go through this, it has to do with this. So if we look from here, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's the 12th spot, right? So I bet if we look at this first string, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12. Yep, there's already a result in that spot. So we're losing the result. We're losing that result because we're using the OR. We're using the OR here, right? Well, there's already a 1 there. So it's not going to count it. Yeah, so that's a... Should have caught that a long time ago. All right. Yeah. Should have caught that a long time ago. All right, let's... Alright, something came up. I gotta end the stream early. Well, it was actually kind of late. Anyway, catch you next time. Bye.